demonstration yesterday. I know a lot of you would probably like to have one of those type of machines, build it yourself, but it's definitely quite complicated because it's such larger scale, takes a lot, costs quite a bit more money, and there's a lot of learning involved. Even though you have every single little detail in Eric's presentation to be able to replicate it, it takes quite a bit. So, but if you are interested in a smaller scale variation of a longitudinal one-wire type of transmission system, that's what this next presentation is going to be about. Adam has been working in auto mechanics since he was about 15 years old in high school, and received a state smog inspection license, and he was doing this during his high school time. And he spent about 6 years at the University of California, San Diego, and then he started a family of 7, and began his professional career in 1984 as an electrical engineer, working on high-power transmission line development, xenon lamp systems, and computer telephony. And then after that, based on this knowledge, he started with ASIC development for many types of medical products. And then after an extended period of designing power switches and microwave sources for use by the military, Adam returned to the medical industry in cardiac ablation generators and defibrillators. And so he has been kind of moving on the path of experimenting with some of these type of technologies when he learned about the work of Dr. Mile, and has had the opportunity to meet with him and review his work. And as some of you may know, Mile has some of these little experimenter kits on these little one-wire systems, but there's different features that maybe could be included in it for people to make it easier for everybody to learn about these longitudinal type systems. Adam is really a brilliant engineer, very, very generous with his time, and he's brilliant with the math. He understands it. I went over to Adam's house with Eric Dollard, and I'm sitting there just listening, and they're talking back and forth in a language that I don't really get. And he's one of the few people that I've seen talk with Eric at great depth on the math, specifically dealing with these type of technologies. And he has spent hours and hours and hours working with Eric with a lot of field mapping experiments, and dealing with actually Eric's presentation. There was a few of the diagrams. There was a few handheld diagrams. There's a few handheld microphones. There's a few diagrams in Eric's presentation that came out of Adam's work, and so I would say give Adam a round of applause for all his contributions. Lots of knowledge. So anyway, welcome Adam Griffin.
Microphone working?
Yeah.
Thanks for coming, everybody. So part of what Aaron said was incorrect. Hardly, though. I think I had learned about this technology when I saw Eric Dollard's videos, the ones that I think you put on there, and it showed me this new technology that I could not believe. And then I looked for a way to check it, and then I was able to purchase some stuff from Dr. Mile. And I made a trip over there, see what he's doing, found one error in his book. But basically, Dr. Mile knows who he's talking about. He wrote the book on this radiant energy. And this is the product that he sold me. It consists of a primary on the back and a secondary on the front, but it's not complete. So I reverse engineered this and made my own, and included all of the stuff that wasn't on this one. So I'm going to pass these around. Maybe they can zigzag through the audience and end up with Andrew, my son. Where are you, Andrew?
I got you here.
Over here. So Andrew will pick these up when we're done. Can you send those around just so people can compare what Mile did with what I did? So when I reverse engineered his board, all I did was figure out the length of the coils. And then I implemented that on my own with the same length, because the length determines the operating frequency. So So he's using 1 ounce copper that's this thick. I'm using 6 ounce copper and so I'm able to put a lot of current in my device. So let me show you something here. This is the transmitter that I built, and this is the receiver. If anyone wants to pre-order these, they can. Aaron's already got the channels open
I'll
up.
give everybody the details.
Yeah, if you want one of these kits, you can do it. If you want one of these, you can buy it from Dr. Miles. Now, I'm going to push this button on this transmitter. What it's going to do, it's going to step through the frequencies, and it's going to illuminate the receiver's LED when it hits the resonant frequency, longitudinal wave frequency. And then what this does, it actually can sense what the receiver is doing, and then it tends to adjust itself such that that'll stay lit up. So there's software on this. There's actually, you can connect this to a computer monitor. You can type in the frequency and stuff. But I have a mode here where I just push this button and it'll do a hunt. Can these lights be turned off? Right now it's stepping through 32 frequencies. It's looking for the one one of them is going to illuminate. There's the illumination frequency there where it's stepping through them, and I'll do that one more time. Push this button here. Transmitter resets its frequency to low, and it's ramping up its frequency, and when it hits around 7 megahertz, this LED is lit up, okay? So when you get the most brilliant intensity there, that's when the longitudinal wave is propagating. And these two are connected with just one wire. So next, let's look at Dr. Miles' kit. So I engineered this so that it would be compatible with this kit. And what I'm going to do is this here uninterruptible power supply. I'm just going to unplug it. This is what's been powering my unit, this supply. And I guess I'm going to turn it off. There. No transmitter, okay? Transmitter is not powered up. This UPS is disconnected. Transmitter is here, receivers. Okay, now let's turn on Dr. Miles' unit. What I've got over here is the equivalent of what is on my circuit board. It's a scope, generator, an amplifier. My board has some more smarts on it. It actually has a way to measure stuff in a computer. Let me turn this on. This is a one-wire system as well. Right now I've got 1 amp at 15 volts, 14.7, so that's 15 watts in the input. I've got an amplifier here, maybe it's 30% efficient. So there could be 5 watts over there lighting up that bolt through one wire. And I can optimize the frequency here. There's the scalar wave is running here at 7 megahertz. But why is mine on? Okay, so the reason this is on, I don't know why. But it's tuned to the same frequency. This should not be working. It's more effective with a wire. It's even more effective if you connect the wires in. And so there's very high electric fields going on here. This field is being generated somehow, and my impression is what's happening here is this is at the same potential as that. So this is a counter electrode, it's like the minus, and then here's the plus connected together through this wire. Here I can't explain to you what's going on, I don't know. I have the mathematics to do it, but I don't have access to government computers.
Will that neon tube light up by the smaller one? By yours? Wow.
Yeah. This means there's like several thousand volts per meter over here. Yeah, so this experimental kit here contains everything that Dr. Miles' kit does, including computer and a user interface. You can set the frequency with your keyboard. You don't have to go and have an expensive generator. You don't need a scope so it can measure stuff, but you can hook a scope up to this. You can type in commands like mez, it'll measure how much it's reading. Freak, you can set the frequency. I've got an instruction guide, tells you the commands. got a schematic. So on my YouTube channel, on I think you look up griffin.adam.h@gmail.com. I've got 3 videos up there. One of them is this experiment. One of them is actually where I use flat pancake coils. You don't have to use a scatteron that's round. You can use a scatteron that's flat if you know what you're doing and you have to do something to the board. So I guess that's the end of my demo. Oh, and Aaron has a demo, a video from last year where I showed the user interface running.
How far away will that light bulb light up from? Will it work going towards the supply over there, the generator? Follow that line?
This? You mean, can you?
The red one. The red one. Light bulb? Is that a neon?
Oh, well, this is a just a standard reveal kitchen lamp. Now, they don't stay illuminated along the wire. Okay? You have the longitudinal field along this wire here. There's a high field along this wire. You put it too close to the earth, it'll absorb into the earth and it won't work. So Aaron has one more video on his channel about this. He's got a place where he's offering these for sale, I believe, and that's going to come online soon. This kit, you want to buy this kit from Dr. Mile, you can do that too. It's a good kit. It's good for transmitting power, you can see here, but it just doesn't have all the utilities that I needed. I needed a function generator, built it on there. I needed something that would sniff out and sense stuff. I built it on there. I needed to be able to program it so it can run a program. I'll let you know where all this technology is going. I've got practical applications for this. One of them is called the pole kit, and that, if you want to read the business plan and stuff, it's a $13 million 2-year to take this technology and compete with, say, SEL Labs. They have a pole kit now that runs on a radio. This one can run on a longitudinal wave with one wire. And the next step of that would be to build Tesla's towers, use this technology in order to meter. So I've already copyrighted the term LEXMA, LXMA. People might have heard of CDMA, TDMA. Well, this is LXMA. Longitudinal, X is either like time division, frequency division, multiple access. Longitudinal, something, multiple access. This is what the power companies will have access to as the final step in this program. If there's any questions, I'll answer them.
What are the practical applications for this?
One practical application is the pole kit, which allows the power companies to determine whether or not the power lines are down and where. So you put one between each pole, it uses the existing wiring, and if there's a energy problem, somebody's neighborhood's shorted, they know where it is. It relays it up to the central office. The other practical application is to use this computerized system such that a large Tesla tower can send energy to subscribers and meter it. The technology is here now to meter it such that it doesn't get shut down by the power companies. The power companies would own this, is the idea. The LEXMO, longitudinal multiple access.
What's the application for Dr. Miles' product?
I don't know.
I have a question.
I think it's for learning.
I have a question. And Miles says that when he hits the proper frequency, he can put his receiving tower or whatever inside a Faraday cage, and it still doesn't block the signal. Would that be true of yours? And the other question is, he says that at that frequency, he can have numerous receiving towers, and they will all receive the power, and he's actually winding up receiving more energy than he's putting into the sender.
Okay, so I'll address your second question first. Yes, I have some papers that I've written on this fact that you can take one transmitter and daisy chain it out to multiple receivers. If anybody's interested, contact Aaron. He'll probably get you these papers I've written.
And you're receiving more energy than you're putting in.
No, you receive the same amount of energy you put in, unless you're in an environment with sympathetic transmitters. You can pull them in. So if you're in the neighborhood of some other longitudinal waves that are oscillating at that sympathetic frequency, then yes, you can pull it in. That's what Tesla was doing. He was pulling in stuff from outer space energy, but you have to be at a resonance that you can pull that in, like tuning fork. You got a tuning fork, set one off over here, this one will start vibrating.
And it's not blocked by a Faraday cage.
The tests I've done say that's correct as well.
What's that?
The tests that I've done suggest that that's correct. That
Okay.
you are not able to block this longitudinal wave, and that's I think part of why this technology hasn't gone very far, because I suspect that the government uses this for things that they don't want to know.
These papers that Adam is referencing, in addition to some of the videos, it's all going to be on Vril.io. If you mouse over the products link, this will be up shortly after the conference. We've been so slammed we didn't have a chance to get all that updated. But the kit that Mile came out with, that was about $1,600, something like that. Adams is a lot more robust. It's a little bit smaller, but you can do a lot more with it, and it's easier for beginners to learn with. And ballpark, it's going to be about half price. And as soon as we get that online and everything to take orders, we'll give a conference discount. But everything is already set with the same company that manufactures the Bedini RPX sideband generators for me. Everything is set to just submit the orders, push the button, and expedite it. I think they can do it around 4 weeks, and if not, then about 6 weeks, 8 weeks, ballpark, something like that. So they'll definitely be ready to ship. It's not something like taking orders and we have to figure out how to, get it produced and everything. It's turnkey and ready to go.
We've also got some fun photos where my friend Arnold, who sent me this back from New York, he borrowed this, took it over and went to Tesla's hotel room area, the Radio Waves building. So there's pictures of this actually on next to his plaques and stuff. If anybody wants to get that, Aaron can provide that too.
Question?
Yeah, I've got one quick question. So in Constantine Miles' work, he talks about using or being able to transmit medical information, or not medical information, but medicine to people through these waves. Have you played around with that at all?
I attended his conference, and I don't think I don't think it's readily provable. Yeah, and his claim is that the myelin sheath of the nerves carries the longitudinal waves in the human, and this is why cell phones make it so you can't heal so well, your cells can't talk. But as far as taking ant poison and delivering it from one to another, I tried that. I couldn't kill ants. I attempted to do something similar to what he had. I had poison. I tried to impress this poison on the water by putting it on the corresponding. At that point, when I brought that up to Dr. Mile, he stopped communicating with me. That was by email. So if you want to see the ant test, you're free to look at that too. But the result was no. Thank you. It wasn't no, it was no.
Okay, one final question.
You say you could potentially deliver these to subscribers. So what each subscriber will have to receive the power?
The way this works, the Lexma copyright that I've got is somewhat protected. It's least protected the acronym. Is each subscriber has a receiver module. The transmitter module is a giant tower somewhere within range, and the receiver module pings the transmitter and obtains access, because you can transmit data or power with this. Once the access is transmitted, the receiver adjusts their frequency. Then the transmitter dumps some slugs of current over. And that's why it's multiple access, because the transmitter dumps a slug, goes to the next subscriber's asking for power, dumps a slug over there. These slugs end up going into a battery or something regenerated in AC, 60 hertz. This stuff is probably going to run at around 7-10 megahertz.
Okay, well, thank you very much, Adam Griffin.
Thank you, everybody.
Will this be around this weekend, or hang out for a bit to do the demo in the back room, or people wanted to get up closer to look at all this stuff, or? It depends on your schedule.
Okay.
So we'll just take a quick 5-minute break and then we'll get started with the next presentation.